Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we're looking at the 2019 exam paper, where our focus will be on linear regression. This is a section of statistics, and we are looking at grade 12 mathematics. So the first question from the 2019 November exam, it reads, the table below shows the monthly income, that is in rands, of 6 different people and the amount of money, which is in rands, that each person spends on the monthly repayment of a motor vehicle. So we're given the table, then the first equation requires us to find the equation of the least squares regression line of the data. So if you look at 1.1, what they want us to figure out is what is y equals ax plus b, which in other words means we should go and figure out what is a and we should figure out what is b. And for this section, part of the paper, guys, it's very simple. What you should do is use your calculator. That's all what you need to do, okay? So you just need to use your calculator. So the value of a, I'm going to go to my calculator and quickly populate our table. Okay, -1. So we can go to data. So this already has something here. I'm just going to clear it. And then there we go. So what you should notice that in your table, you'll put in the x values and the y values. So let's go and start. 9,000 equal to, we have 13,500. Then equal to, we have 15,000. Then we have 16,500. Then we have 17,000. Then we have 20,000. Okay. Then let's go and put in the y values. So for the y values, you have 2,000. Then you have 3,000. Then you have 3,500. Then you have 5,200. And then you have 5,500. Then you have 6,000. Okay. So that is what you have. Let's quickly confirm. So 2,000, 3, 3.5, 5.2, 5.5, 6. Okay. That looks about correct. So let's go ahead and then read our values. So we'd say shift stats, then reg, which is for regression. And then now I'm in a position where I can read the A value. So this is saying empty. So my calculator cleared that. I just need to populate the table again. So I'm done populating the table. So let's see if we can now read the values of A and B. Right. So there we go. So let's quickly note down the value of A. So that is negative 1,946. Point, I'm just going to make it to be 3 decimal places. So it's 875. Okay. Then let's go for the value of B. Shift 1, stats regression, and we go for B. And you will see that the value of B will be, that is times 10 to the negative 3. So that's 0.405. Okay. So this means that we can now write our equation. Our equation will simply be negative 1,946.875, then plus 0.405. This is multiplied by x. So that becomes the equation that we're looking for on question number 1. So next, which is 1.2, we are required to figure out if a person earns 14,000 per month, predict the monthly repayment that the person could make towards a motor vehicle. So what you should note is that we're given that x is 14,000 and what we are looking for is y. So what I'm going to do is to use the equation. So our y is going to be negative 1,946.875, then plus 0.405 into 14,000. So let's go ahead and punch this on our calculator. So we have negative negative 6.875 plus 0.405 times 14,000. And what we end up getting is 3,723.13. So this means here that our answer, we can say that a person earning about 14,000 is more likely to pay about 3,723.13 rands for their motor vehicle. Okay, so this is our finding according to this equation of ours. Right, so let's go to 1.3 then. So in 1.3 we are told determine the correlation coefficient between the monthly income and the monthly repayment of a motor vehicle. So what we are looking for is what we call the correlation coefficient. And what the correlation coefficient is, it is indicated by R. So essentially, the question is, what is R equal to? And as always, for this section, guys, all you need to do is to go and use your calculator. Okay, so our calculator is all what we need. So let's go to it. Right, so if you observe carefully, we're now on our calculator. So Shift R. Now, if you look carefully, there's our R value. So it's 496. If you round that off, you will see that our R value will become 0.95. Okay, that is what the R value is going to be. And what I need you to remember is that an R value that is very close to +1, that indicates, we covered this in the introduction lesson, a strong positive correlation. Okay, so this is very important. And once we have strong, what this means is that what we estimate or what we predict is accurate. So once we have strong, that means our predictions are accurate. Okay, if the data follows the same trend. Right, now let's go to 1.4, see what's happening there. So for 1.4, we are told a person who earns 18,000 rands per month has decided whether to spend 9,000 as a monthly repayment of a motor vehicle or not. If the above information is true, if the above information is a true representation of the population data, which of the following would the person mostly likely to decide on? So spend 9,000 per month, that's option A, because there is a strong correlation between the amount earned and the monthly repayment. Not spend 9,000 rands per month, because there is a weak positive correlation. So what we should note is what they are saying, okay? And then spend 9,000 rands per month because the point lies very near the least squares regression line. And then not spend 9,000 rand per month because that point lies very far from the least squares regression line. So what I'm going to do is I'm going to figure out if this person is earning X, which is 18,000, according to our equation, what is our Y supposed to be? Okay, that's the first thing that I'm going to try and figure out. So our Y will simply be what we have, -946 0.875, then plus 0.405 into 18,000. So I first need to figure out this y. So you'll see that we have negative 946.875 plus 0.405 into 18,000. So what we end up finding is if this was following the least squares regression line, this person was supposed to be paying about 5,343.13. Okay, this is following. This would be the case if this was following the least squares regression. Okay, squares regression line. So if you look carefully, clearly the person is not following that because they were supposed to pay about 5,300 while they want to pay 9,000. Okay. So what I'm going to do is, remember, we found the correlation to be 0.95. Now, what I'm going to do is I'm going to add a person who's earning 18,000, but they want to pay 9,000. So that you see the effect on the correlation. Okay, shift 1. So let's come here, that. So I want to add a person who's earning 18,000, but that person wants to pay 9,000. Okay, now let's go and quickly have a look at our regression. And I specifically want to focus on R, shift 1, then R. So if you look carefully, our R now has become 0.8. Okay, if you round it off to 2 decimal places. So this means now our R now has become 0.8 with the point where someone is earning 18,000, but they want to pay 9,000. So our coefficient of correlation is decreased, meaning this here is out of the norm according to our regression expression. That is what the expression is telling us here, that this here is out of the norm, out of what we were expecting. So let's see which one of the options we are supposed to choose for 1.4. Okay. So for A, they are saying spend 9,000 because there's a strong positive correlation between the amount earned and the monthly repayment. Not spend 9,000 because there is a very weak correlation between the amount earned and the monthly repayment. Spend 9,000 because the point lies very near the least squares regression line. This we know is not true. Not spend 9,000 because this point lies very far from the least squares regression. So what I would take would be this here, because 0.8 is not weak. Okay, but definitely the point, it influences our correlation coefficient. It's a bit far from 5,000. So what I would put up here as an answer is D. Okay, I hope that this does make sense and you guys understand the thinking. So with this in mind, let's move to the next question, which is question number 2. This is still from the 2019 paper, but this is the June version. So we are told learners who scored a mark between 50% in mathematics tests were selected to use computer-based programs as part of an intervention strategy. On completing the program, these learners wrote a second test to determine the effectiveness of the intervention strategy. The mark as a percentage scored by 15 of these learners in both tests were given in the table below. So we are supposed to determine 2.1, the equation of the least squares regression line. So we are supposed to go and figure out what is A plus BX. What that pushes us to ask ourselves is, what is the value of A and what is the value of B? And for this, as I always say, what you should do is use your calculator. So this section is very simple, guys. We are just using our calculator. So let's go ahead and I show you how to do that. Clear? Shift 1. So you should say Shift 1 and then you'll see data, and you can select stats where you see AX plus A plus BX. So I'm going to remove this and I'm going to try and put in this data here. So I'm going to have a 10, then 18, if you look carefully, 23, 24, 27, 34, and 34, 36, 37, 39, 40, 44, 45, 48, 49. Okay. Then I'm going to go and put in the corresponding Y values, which is just test 2, that is 33, 21, 32, 20, 58, 43, 49, 48, 41, 55, 50, 45, 62, 68, and lastly 60. Okay, so that is what we have as our table. So I can now go ahead and read the value of A. I hope it's not going to clear my table. Okay, did not. So if you look carefully, we have found the value of A. So the value of A is 11 point, I'll just make 3 decimal places, 364. Okay, then let's find the value for B. Shift 1 and then B is that. So for B, we're getting 0.934. Okay, so therefore we can write our expression, which is Y equals, if you observe carefully, 11.364, then plus 0.934 times X. So this here, guys, is our answer. So that is our answer. Next, let's have a look at 2.2. So in 2.2, we are told Elena's mark in the first test was 15 out of a maximum of 50 marks. So we need to write down the learner's mark for this test as a percentage. So that's very simple, 2.2.1. So remember, this learner got 15 out of 50 marks. So as a percentage, that becomes 15 over 50, and then multiplied by 100%. So, or just multiplied by 100. Okay. So if we have 50 divided by 50 times 100, so this, you will see that it will end up being 30%. So we can safely say that the learner got 30%. So let's go ahead. The learner got 30%. Okay. Now let's go to 2.2.2. So 2.2.2, they say predict the learner's mark for the second test. So remember, X is telling us about test 1, of which the learner got 30%. Now we are worried about Y, which is test 2. What mark did the learner get? And guess what? We are going to use our equation. So we have Y equals, our equation is 11.364 plus 0.934 into, we have 30. So this will be equal to, let me use my calculator, 11.364 plus 0.934 into 30. And what I'm getting is 39.4. Okay, this will be in percent. So that is what the learner would have scoring. So let's put up that as an answer. In that, according to this regression line, the learner would likely score about 39.4% on test 2, which is what we are interested in. So on test 2, they might score just below 40%. If on test 1, they scored 30%. Okay. So let's go to 2.3 now, where we are told for the 15 learners above, the mean mark of the second test is 45.67. So essentially, if we look at test 2, which is y, so the mean for y, that is 45.67%. Okay. And the standard deviation, so we're looking at the standard deviation for y. So that standard deviation will simply be 13.88%. Then they say the teacher discovered that he forgot to add the marks. Sorry, the teacher discovered that he forgot to add the marks of the last question to the total for each of these learners. All learners were scored full marks for the last question. When the marks of the last questions were added, the new mean became that. So now we have a new mean, where the new mean now became 50.67%. Now, the question is, what is the standard deviation after the marks for the last questions are added to each learner's total? So what you need to note is that with the standard deviation, even if you add or you subtract marks, it doesn't change because every point moves by the same amount. So for our 2.3.1, what we can say is, what is the standard deviation? So we can just say the standard deviation is the same as what we have. It's 13.88%. Okay. And then now if we look at this, if the standard deviation is the same, what was the total mark of the last question? So remember, everyone moved by the same amount. So if we take the average and we take the differences in the average, we should get the answer. So 2.3.2, what you should get is this 50.67 minus our 45.67, and that gives us about 5%. So it means the last question contributed 5% to the total mark. So the last question was worth 5%. Okay, that is what the last question was worth. So I hope that this does make sense to you guys. Let me quickly go to my table. I want to quickly check something, the correlation. So the correlation is 0.6. Yeah, I'm doubting this one. Let's quickly double check our table, guys. So yeah, the correlation being 0.6, that's very questionable. That is very questionable. So let's have a look at what is happening here. So we have 10, 18, 23, 24, 27, 34, 34, and then 36, then 37, 39, then 40, 44, then 45, then 48, then 49. Okay, let's look at the second one. We have 33, 21, 32, and then 20, 58, 43, and then 49, then 48. Okay, 48. Okay, and then after 48, we have 41, then 55, and then 50, then 45, then 62, then 68, then 60. Okay, so yeah, that correlation factor was very suspicious. So yeah, we need to quickly rectify something here, guys. Right, equal. So let's go ahead and fix our equation, our regression equation. So A, so let me see if this did get fixed, because I'm still getting the same value. So this here should be 48 equal to, then we step over all of these until the last one. So let's go and try again. Variable, so we're looking at regression A. So if you look carefully, now I'm getting a different A value. Okay, so the A value that I'm getting is 12.441. Okay, and let's go for the B value, shift 1, B. So the B value, if you look carefully, that becomes 0.981. Okay, so now we can just quickly rewrite our expression, which will be 12.441 plus 0.981 times x. So that is our answer, and we can now go ahead and quickly correct what we have here. Okay, and that there. So our y will be 12.441 and then plus 0.981 into what we have is 30. Sorry, we have 30. So let me quickly use my calculator. So I have 12.441 plus 0.981 into 30, and what I'm getting is about 41.87%. So we can say this person is more likely to score about 41.9%. Okay, that is just rounded off to 1 decimal place. So I hope that this does make sense to you guys, and you actually genuinely understand what we are doing here. Okay, you can round up your percentages to 1 decimal point, that's okay. But yeah, this brings us to the end of this lesson, guys. I hope that you do understand everything. And as always, this is brought to you by, you can take a guess, it's brought to you by iCampSA. So please spread the gospel of passing, share with friends, classmates, and others to make sure that we all pass. So let's pause here for today, guys. Please make sure you look at the approach that we took, rectify any mistake if you do come across. Look at the questions step by step. Make sure you are able to use your calculator. So here we're doing the 2019 exam, June, and the November exam. Cheers, guys. Take care.